Alright, so this is a quick synopsis of Unit 3C where we did the interest problems and systems. So if you remember this formula at the top, Y is your final amount. So whatever that means, money, it could mean people, whatever the case may be, your final amount. A is your initial amount, so wherever you start. R is your rate, and remember we always convert that from a percent to a decimal. Okay. And then X is your time period, and you guys remember that isn't necessarily like number of years. It kind of depends on the problem and what you're talking about. So if you look at number 1, it says the town's population has increased by 21%. Over the last 8 years. The population is now 82,473 people. What was the population 8 years ago? Okay, so if you look at how the problem is written, it's increased by 21% over the last 8 years. So that means that when they're asking what the population was 8 years ago, this question is asking for the A value. So the population is now 82,000, that's your Y value. So 82,473. We're looking for the A value, and then we have 1 plus 0.21 because we're going to write that percent as a decimal. Now, you guys, we don't put 8 here because then what you're saying is that the increased 21% each year for 8 years, which wasn't the case. What you're saying is it increased 21% over a time period of 8 years. So that's just going to be a 1 because it's one time period. This 21% isn't an annual rate, it's a time period rate. Okay, so we end up, we know anything to the first power is itself, so we really end up with 82,473 equals 1.21 times A. Okay, so if we take our calculators and we take 82,473, divide that by 1.21. All right, so remember we're dealing with people here. Okay, I'm going to round up because it's a 0.5. So our initial population was about 68,160. Okay. So that would be your population 8 years ago, which, according to the wording, is your A value. Now, the next question is saying, what is the annual rate of increase? All right, so annual. This 21% is over 8 years. We want to know what happened every single year. So we have our final amount, which is 82,473. We now have our initial, which is 68,160. I am looking for an annual rate of increase, so that's my R. Now here I do use the 8 because I'm looking for the rate that happened annually for 8 years. So now this is where I'm breaking it up. All right, so we're going to do a couple things. I'm going to kind of do this and then I'll pick up the calculator. We're going to divide by 68,160 on both sides. Okay, so those would cancel. You're left with this, so remember now you need to raise this to the 1/8 power. Okay, and in your calculator, we have, let's see, 82,473 divided by 68,160. We're going to raise that to the 1/8 power. So we get 1 point, we're going to do 4 decimal places here, 1.0241. So we get 1.0241. Remember, that's technically equal to 1 plus R. So we still have to subtract our 1 away to get R by itself. So R is approximately 0.0241. So the annual rate of increase was about 2.41% increase per year. Okay. So it's 21% over the long haul, but it was 2.41 each individual year. Now, the next question says, assuming the annual rate of increase stays the same, what will the population be 5 years from now? Okay, so you guys think now. Now, we're talking the population of this. This is what now is. Okay, so there's two ways you can look at this. The first thing, or first way, excuse me, you can say it is that we're looking for Y. If you use the original initial population, which is 68,160, and you have, what is this, 0.0241. Okay, well, this happened 8 years ago, okay? And we want 5 years from now. Well, 8 years ago plus 5 years would be a total of 13 years from this population. So that's one way of doing it. The other way of doing it is say, okay, from now, well, my population right now is 82,473. My rate's not changing. But if I'm using this initial population that's happening right now, so then I'm looking for the 5. Okay. Either way, you're going to get answers that are pretty darn close. So if you throw that in your calculator, you get 68,160 times 0.0241 to the 13th power. So your population is about 92,892. 92,892. Okay. If you do it the other way, you have 82,473 times 1.0241, and that is going to be to the 5th power, and you get 92,901. So if you look, they're really close. I mean, you're off by what, 7 people, which makes sense. I mean, we had to round and all that. So it doesn't really matter how you do it. Either answer would be acceptable. So you're looking at about 92,900. Either way you slice it. Okay. All right. So that takes care of the rates and all of that. Okay. So just remember those 3 steps. Finding A, you always use an X value of 1. Okay. You might want to make that note. When you find A, you always use an X value of 1 because it's a time period. Then once you look for the annual rate of increase, that's when you switch your time to the number of years. Okay. All right. So now we're going to talk about systems real quick. This one says a water balloon is being launched off of a cliff into a lake. And follows the path of that in standard form, where X represents time in seconds and Y represents height above the water in feet. A bird is descending toward the lake following a path of that, which is a linear equation, where X also represents time in seconds and Y represents height above water in feet, so X and Y are the same in both equations. Will the balloon hit the bird? If so, how far above the water will the bird get hit by the balloon, and after how many seconds? Okay, so we're looking to see if they're going to intersect, if they're going to collide, if they're going to hit each other. So I'm going to take negative x squared plus 10x plus 39, and I want to know if at any point it is the same thing as the bird. Okay, are the balloon and the bird going to hit each other? That's the main goal. Or hopefully not the goal, I guess, but that's what we're looking for. Okay, so remember when we're solving a quadratic, we want everything to one side. So I'm going to bring everything to the right side so my x is squared becomes positive. So I'm going to add x squared over here, subtract 10x. Obviously, some of you might not need to show this step, but if you find yourself making small mistakes because of algebra, make sure you show all your steps. We have 0 equals, this ends up being x squared minus 10.8x. 19 minus 39 is a negative 20. Okay. I'm totally going to double check that because I'm not trusting my math this morning. Awesome. Okay. All right, so you guys, if you look at that, I'm taking one look at that and thinking, forget factoring because there is a decimal. So I'm going to go straight to quadratic formula. So x equals the opposite of b. Oh, hello. Okay. Hold on one second here. All right. X equals, as I was saying, sorry. Opposite of b, so 10.8 plus or minus the square root of negative minus 4 times A times C all over 2 times A. Okay, so I'm going to get that discriminant taken care of first. So we have negative 10.8 squared minus 4 times 1 times negative 20. Okay, so our discriminant is 196.64. So x is 10.8 plus or minus the square root of 196.64 all over 2. All right, so you guys, that's going to get us two answers. We have 10.8 plus the square root of 196.64. And then we have to divide that by 2. So one of the answers is about 12.41. Okay, and then your other one is 10.8 minus the square root of 196.64. We divide that by 2, and we get negative 1.61. Okay, so let's remember what we're solving for here. X represents time in seconds, and Y represents height above the water in feet. So, will the balloon hit the bird? That answer is yes, because we have intersection points. However, this one is a no-go, because if X is time in seconds, it's not going to be a negative. So, yes, it's going to hit the bird. Okay. So, yes, the balloon hits the bird. And it says, how far above the water will he be hit by the balloon after how many seconds? He gets hit after about 12.41 seconds. And he is, okay, we need his height above the water. Okay, I'm going to go back to the easier equation, which is the y equals negative 0.8x. I'm going to substitute in my 12.41 plus 19. Oops, sorry, guys. So we end up with negative 0.8 times 12.41 plus 19. He's about 9.072, so about 9.07. So, and he is about 9.07 feet above the water. Okay. So, that's what you do for systems. If you're looking for things to intersect, then that's what you have to do. You have to set them equal to each other. If it factors, that's awesome. That's a little quicker than quadratic formula, but if you're not finding that it factors, or in our case the numbers came out ugly, so we used quadratic formula for that, then you're good. Okay, so quick synopsis for you for 3C. As always, let us know if there are questions. Okay.